Just like we have different rules for properties of exponents, there's different rules or properties for logarithms. So the product property is if you have log base b of two quantities that are being multiplied, you can split this apart and the multiplication turns into addition. And if you have the right hand side, which you have the same base, make sure you have the same base, and you're adding two logs of the same base, you can put them together and multiply. So if you start with the left hand side, you can get the right hand side, and if you have the right hand side, you can write it in the left hand side. So there's the product property, which is when you're adding logs, the quotient property is when you're subtracting logs, and the power property is when the coefficient or the number out in front or the expression out in front of the logarithm is actually the exponent. So part 1, assume that log 3 is approximately equal to this, log 4 is approximately equal to this number, and log 5 is approximately equal to this number. Use the properties of logarithms to evaluate each expression. So if I look at log 12, I don't see anything here of log 12. But you need to think about how can you make log 12? Well, 12 is 3 times 4. So this is log 3 times 4. And using the product property, I can actually write this as log 3 plus log 4. So now if I know the value of log 3 and I know the value of log 4, it just means I need to add these two quantities together to give me log 12. So what you're doing is you're trying to break down these numbers and look at how you can decompose 16 to be 3, 4, or 5. So if I'm looking at 16 is, I don't know how I would get 3 from that, but 4 squared is 16. So I'm going to write this as log of 4 squared. So using the power property up here, right here, you can actually put the 2 in the front. So it's going to be 2 log 4. So what that means is you're going to take 2 and multiply it by the log 4 expression. So 2 times approximately 0.6021 is going to give you that log 16. And then the third one is log 3 over 5. So we have 3, we're going to use this property up here. So this is going to be log 3 minus log 5. And I have log 3 and I have log 5. So I can just subtract 0.4771 minus 0.6990. And the last one is 0.8. So 8 tenths. So I'm going to write this as 8 tenths, which is the same thing as log of 4 fifths. So I'm going to use the quotient property, and this is going to be log 4 minus log 5. So just make sure that you always write, when you're using the quotient property, you write the numerator first. The numerator comes before the denominator. So then you could calculate this minus this. So let's do more of these, writing as a single logarithm. So make sure they always have the same bases in order for you to combine them. So this has the same base of 5 and I'm adding. So this is going to turn into log of 4 times 3, which is 12. Keep the base 5. Number 12, I'm subtracting. So remember, when you subtract logs with the same base, you actually turn it into division. The first number, the first expression becomes your numerator. So this is going to be log 6, base 6 of 25 divided by 5, which is 5. 13, go from left to right here. There's no parentheses, so you make sure you go from left to right. So this part is going to be log of 2 times 4, which is 8, minus log 2a. So you could either write this, okay, I'm going to write this as a single log. I'm tempted, I just want to put 0 right now because it would be 0, but I'm going to write this, if I'm subtracting, it's going to be log base 2 of 8 divided by 8 is 1. So log 2 of 1 would be 0 if you evaluated it, but I'm just writing it as a single logarithm. And then number 14. Now I have to run to the first part where if I have a quantity in front of the log. So remember, that turns into your exponent. So this is going to be log base 7 of x to the 5th minus log base 7 of x squared. So when you're subtracting, you're going to write these as this is your numerator and this is your denominator. So if you're thinking about doing x to the 5th divided by x squared, you're going to subtract these exponents. So this is going to be log base 7, subtract the exponents of x cubed. And then number 15, going from left to right, I'm subtracting these two quantities, so that means I'm going to divide 60 divided by 4, which is 15. So it's log base 4 of 15 plus log base 4 of x. Now you're adding these two logarithms, so adding turns into multiplying. So the answer is going to be log base 4 of 15x. And then number 16, go from left to right. You are subtracting those, so you're going to divide that. So it's going to be log of 7/3. And then you're going to multiply this by 6. So you're taking this quantity and multiply it by 6. So this turns into 6 times 7 is 42, divided by 3 is 14. So this turns into log of 14. And then number 17, you have a number out front, so it's going to become your exponent. So I'm going to write it as log x squared minus log y cubed. You're subtracting these logarithms, so I'm going to write this as division with this being my numerator and this being my denominator. So it's log x squared divided by y cubed. And then number 18, you have a number out front again, so it's 1/2. So if you're going to have r to the 1/2 power, the 1/2 power actually means the square root. So I'm going to write this as log square root r times, because I'm adding these two. Now if s is to the 1/3 power, that's the cube root. So I'm going to write the cube root of s. And then what I'm doing is I'm subtracting. So remember, when you subtract, you're going to divide. So I'm going to divide by the 4th root of t. So the 4th root of t. So this is my answer. I just wrote it all at one time. This whole expression. There's nothing I can really do to simplify it, besides I could get rid of this 4th root by multiplying the top by the 4th root of t 4 times, but nothing can be simplified because I have the square root and the cube root and they have different indexes, so I can't do anything further with that. And then 19, this part is going to break up into log base 3 4x plus, so you're going to multiply it by this whole quantity is going to be squared. So make sure you square the 5 and the y. So if I square the 5 and the y, it's going to be 25y squared. So now I'm going to simplify this part. This turns into log base 3 of 100 xy squared. Okay, the next part is to expand it, which means you're going to decompose, you're going to break it down. You have to figure out if it's multiplying, dividing, if there's an exponent. So right here, all three of these are being multiplied, so we're going to break them up with addition. So it's log x plus log y plus log z. And then number 33 is you have your numerator, and this is your denominator. So I'm going to write it as log base 2 of x minus log base 2 of xz, or yz. So now you can break it up further because these two quantities are being multiplied. So I'm going to write this as log base 2 of x minus Now, I'm subtracting this whole quantity, so I'm going to put this in parentheses because I am going to have I'm going to have an expression with two terms right here, and this whole quantity is being subtracted. So it's log base 2 of y plus log base 2 of z. So you can either not put the parentheses in and make sure that you end up subtracting them both, or just keep the parentheses as it is. And then number 35, what's going on here is that you have log 7 times 3x minus 2 squared. So the part of it that has the exponent is 3x minus 2. So I'm going to break up and write log 7 plus log 3x minus 2 squared. So now this little exponent right here only goes out in front of this part. So I'm going to rewrite it as log 7 plus 2 log the quantity 3x minus 2. And we can't do anything else down here because this is subtracting two quantities. It's not multiplying. If it's multiplying, we could split it up further, but it's subtracting, so we don't have a property that's subtracting. So this is the answer right here. And then number 36. This whole thing is being square rooted. So I'm going to write it as 1/2 log of 2RST over 5W. So it's going to be a lot. So this whole thing has the half out front. So this is going to be 1/2 out front. These are all being multiplied, so it's going to be log 2 plus log R plus log S plus log T, and then you're subtracting the 5 times the W because this is being divided by. So I'm subtracting, kind of ran out of room, the log 5 plus log W. So I had two sets of parentheses going because this whole thing had the 1/2 out front. And then I was careful with my numerator and my denominator. Then I'm subtracting it. So you could go through and distribute the negative through. Or you could distribute the half to everything. And then number 37 is log 5x. So this is going to be your numerator. This is your denominator. So it's going to be log 5x minus log 4y. But now we know that we could write this as log 5 plus log x minus log 4 plus log y. So if you're ever in doubt with these problems, you could take this and write it together and see if you get your original problem. You can check your answer that way.